relationship between three sides, but this time we are using sine. Now we're going to see how we can use these set of equations to work with the problem I just gave you. Because it's the same problem, when instead of doing the graphical part, we're going to use these equations. So let's take the first force, which in this case was 40 Newton, making an angle of 20 degrees. Then we got the second force, which is at an angle of 25, and with the magnitude as 50 Newton. So when you're using the math equations, then you don't need to draw everything to the scale. What you need is an approximate diagram which represents these two forces. Then we're going to take the same point here, join this together, and that's going to become the resultant. So that's the same triangle we did before. The only difference here is that we don't need to have those scales, we don't have to take all the length and all that, we just need roughly to draw these arrows for the first force, arrows for the second force, and then connecting it. Now we want this length, because the length of this arrow is the magnitude for the resultant. We already know this length, we already know this length. This length is going to be 40, this length is going to be 60. So I can use this equation. And if I need to use that equation, I know this length here, I know this length here, so I can simply say that FR square is going to be 40 square plus 60 square minus 2 times 40 times 60. Then we got the cosine, and that's where we start thinking, because now we need this angle. So that angle is going to serve the same purpose as capital C here. And that's not hard to find, because this length on this side is here. So you have this angle is going to be 180 minus 25, that will be 1, 5, and 5. So that becomes 155. And the resultant force FR will be in the square root of, let's say, 1600 plus 3600 minus 2400 is 4800 cosine 155. This is going to be approximated as 97.7 Newton. So that's what gives you the magnitude. The next thing we need is the direction. When I say we need the direction, we're really looking at this angle. We want this angle alpha to find the direction of the force. Because anytime when you look for the force, you need to look for the magnitude as well as its direction. So we found the magnitude, we need to find this angle. And to find this angle, you have to go through 2 steps. First, we work with this triangle, then you can use the law of sine and find this angle first. Once we look at beta. So once you know beta, you can add the 20 to that, and that'll give you alpha. So your alpha is really 20 at the bottom plus beta. And as I said before, that you could find beta by using law of sine. So your second set equations will be, we take this length, which is FR, we just found that as 97.7. We divide this by the angle, which is sine, and the angle we're looking at will be 155 equals, we got this side at 60, and we divide this by sine of angle beta. So that's the that's the equation. That should give us the angle beta. And once you have that form, then it's easy to find the angle. Your sine beta will come out to be 60 over 97.7 and sine 155, and your beta will be sine inverse of 60 over 97.7, and then you have sine 155. And again, if you go through the actual calculations, then this will be approximately 15 degrees. Then your angle alpha will be 20 plus 15, and it's going to add up to 35 degrees. Or your force by itself, means the resultant force Fr, will be 97.7, and this thing was in Newton. Then you have an angle with x-axis as 45 degrees. So that's the second approach of adding two forces. Which means when you draw this diagram, you draw it approximately, then you use one set of equations from law of cosine, you use another set of equations from law of sine, and one gives you the magnitude and another one gives you the direction. Now I'm going to look at one more example.